Now we are going to move on to the second half of today's proceedings. So we have a more focused discussion on one particular sector. It's within broadly electricity slash energy, and how do you think about sustainability and the use of data within those lens. So to introduce the plenary speaker before we get into the panel, let me introduce Professor Rohan Samarajiva to introduce today's plenary speaker.
We are happy to have as our second plenary speaker the Secretary of the Ministry of Energy, Professor Udayanga Hemapala. He was, until a few days ago, the Dean of the Faculty of Engineering at the University of Moratuwa, which has played an incredibly important role in all this work that we have done, and I think in terms of data protection in Sri Lanka. And he will, when in his presentation, I think nowadays everybody can search people on the internet and go to scholar.google. You will see that he has several publications in the use of electricity data, and this was generated by some microgrid work that has been done. I won't get into the details because I think I'll be intruding into his talk. So I think we are very fortunate in having a person who has sort of hands-on experience with data in charge of the electricity sector in Sri Lanka. Professor Hemapala.
Good evening, all of you. First of all, thank you very much for inviting me for this session. And I think most of you from maybe computer or in that sector. But anyway, I will try my best to explain the importance of data as well as the requirement of data protection or the data for the energy sector in terms of, I'm not going to detail about the research side, but I will try to my best to explain the importance of data. Now, first of all, I'll start with the energy transition and the import, because this energy transition, if you understand carefully, you will understand that yes, the data is very important, as well as artificial intelligence or the AI techniques is very important for this energy transition. Now, energy transition in terms of basically again, nowadays we are talking about energy because there are two sectors, electric sector and the petroleum sector. Even our ministry, we have two sectors, power sector as well as the petroleum sector. Now, here what I'm talking is basically the electricity sector. Right, energy transition is a major structural change to the energy supply and consumption. Now, if you basically, if you look at the energy transition, there are two things, like basically energy supply is shifting from fossil fuel based of electricity to production to the renewable energy. Now, if you just use these fossil fuel based system for the electricity generation, actually we don't need much data because those are basically concentrated bigger plants, maybe 300 megawatt or 500 megawatts or even more than that. And then you don't need much data because all the control center and the control logics are based on very few data. Right now, normally if you take the electricity, the Ceylon electricity board, if you take the Ceylon electricity board as only assume the fossil fuel plants, maybe only 5 to 6 using 5 to 6 power plants, we can manage our electricity sector. But when we are moving from these fossil fuel based systems to the renewable energy generations or the renewable energy systems, then the data is very important. Now, why this energy transition is very important? Because we are talking about people-centric energy transition, because even like if you take the Asian Development Bank or any other the donors for this country, always they request to transfer this electricity transition from the concentrated systems to the modernization system, that is we call smart grid systems. That is because if you if you use the basic conventional systems, you can run basic power plants like coal power plants or the other fossil fuel power plants without, as I explained, without an issue. But when you are connecting renewable energy more and more into the grid will there are a lot of technical issues, but basically what is happening is the stability issue. Because why we are talking about stability issue? Because the renewable energy normally not concentrated plants. Basically, these are decentralized. Now, as an example, if you take the solar systems or solar PV systems or normally rooftop-based systems. Now, when you take the rooftop-based system, the issue is during the daytime you generate and then put it into the grid. And during the night, because as you already know, there is no solar, then you have to take it from the grid back. Nowadays, we are talking about this electricity pricing and all these things. The problem is that because if you take the control center, the Ceylon Electricity Board, they cannot understand how much electricity will be generated. Now, assume it's a daytime, how much the electricity will be generated from the solar systems, because it is basically feeding, because those are basically we call as grid feeding systems. It means there is no control basically. Whatever the electricity generate, they basically feed to the system. And as the Ceylon Electricity Board Control Center, they cannot understand how much feed, or they don't have even control. I mean, whenever they want, I mean, they cannot stop, or whenever they want, they can take it like that. That means this is basically now without any control, all the rooftop systems are connected to the grid. Nowadays, now it's I think more than 500 megawatt is there with this solar system. The issue is that because assume today is a heavy rain day. If it is a heavy rain day, there are hydropower plants. They are basically operated next day fully. Then assume next day is a fully sunny day. Then there will be a lot of hydro. Then at the same time there will be a lot of solar. Then what the problem is, the system cannot control, because even this hydro means I'm not talking about the bigger power plants. There are mini hydro, micro hydro power plants. There are no data, right? And if you take the solar system, there is no data. Then sometimes more than 50% of the system basically without any data. That's why always this Ceylon Electricity Board people are saying they cannot control the grid. That's why sometimes actually they are facing a lot of, sometimes this is happening normally during Saturday, Sunday. Sometimes you may feel that the tripping will happen Saturday and Sunday. If the day is a very sunny day, and the day before, if it is very fully rainy day, then the system will face a lot of technical issues. The problem is we don't have data, right? Now, for that actually the requirement is how to get those data, then you need to convert the conventional systems into a smart grid systems. Now, if you have the smart grid system, then it means basically you can have a lot of features are there if your system is smart grid, but at the same time, the smart grid means you need more data. Now, the issue is how can we get the data? Because simply we can say, yes, we can get data. I mean, if you just discuss with all these producers, you can get data. There is no any hiding things, right? It's not like we need, you are talking about unlocking data, but there is no any issue because the data is freely available. The problem is how can we get data? because data is everywhere, like it is scattered. I mean, if you take the country, like everywhere, the data is there. Now, if you need the real-time data, maybe at the moment, I think more than 20,000 customers are there with the solar. Then, if you take in one instance, you will get more than 20,000 data. How can you process those 20,000 data and take a decision? Those are the problems in the electricity sector. This is basically, as I explained, the grid modernization for the smart grid. You can see, I mean, smart grid doesn't mean it's just only the grid, right? The transport, health, industry, homes, cities, buildings, all these becoming smart, right? Then everything can be connected together and we can make a smart environment. But again, the same issue is here, because once we connected all these things, my personal view is getting data for the energy sector is not a big issue, but the biggest issue is basically the communications, because how we can get those data and how to store those data and how to process those data to take real-time decisions. Right, then we are moving from, because as people understood that smart grid is, I mean, even though it came as a concept, right, and then they found that, okay, I mean, realization of smart grid is very difficult. Then people came up with some new innovative ideas. One of the thing is microgrids. That is basically, the smart grid is the bigger system. Then people propose, okay, it's better to implement small grids, and then later we can connect all the smaller grids together and make a smarter grid. That is the proposed sometimes back, and some countries already developed this kind of microgrids. Even in Sri Lanka we have one or two, I think now it's around 2 microgrids are available. Right, and they are basically what we can do, because it's located in one specific area, like assume BOI, one area, then maybe several factories can be connected together, then the communication will not be an issue. Right, otherwise as I explained previously, communication is the biggest issue in the energy sector. Right, the data we can get it because it's a simple thing, because you can put a meter and you can get the data, because even I don't think there is any issue, because there is no personal data. We are not getting any personal data, because all are technical data, therefore those are non-personal data. Therefore we can get those data. The only issue is getting data through the communication system and processing them at the same time and take decisions. Mostly this power sector, we need to take real-time decisions. Then there are some research, even as Professor also explained, we have done some research, and we have microgrids lab in our university, and there may be basically what we have done is to identify whether we can implement this kind of projects by ourselves as well, because this microgrids is again, because we got a microgrid, it is also came from through a grant and developed by a German company, and we try to develop our own systems to see whether we also can develop our own microgrid. Actually, the issue was basically the same thing, because we have seen that when the German people develop this microgrid, again they get all our data, right? And because they have the server and everything, they have the communication, the connections, everything, and they get all our data, but whenever we want, we cannot get it. Right, because again they will say, they told that, like the as per the agreement and all these things, they don't give data to us, right? Even to do research, it's very difficult. That's the problem in this sector, because when a company came and they developed whatever the things, then getting data back is very difficult. That's why we thought of, okay, it's better to develop our own, but it's still, this is also going on. Right. Then if I take example of what any other usage of data. Now, if you just take benefits of any kind of energy projects, when you try to figure out or quantify the benefits to the customer, it's again, we need data. Now, as an example here, now if you just take basically assume as an example when you are making tariff, right? In order to make a tariff, you need to calculate what are the benefits coming from what kind of a project. Because nowadays what is happening when we, that is, as you know, as if you are working in a business company, you know, normally you calculate return on investment and all these things and see whether the investment can be returned within 5 years or 6 years or whatever. But if you just take an energy project, you cannot simply do that, because if you take an energy project, it's not only because there are only not only few stakeholders, maybe mainly when you take a project, there are maybe only 1 or 2 stakeholders. But in energy project, it's not like that. There are so many stakeholders. Therefore, we have to take, we have to quantify the benefits going to the different stakeholders, and then only you can calculate whatever the tariff or whatever the benefit to the customer as well as a whole community, right? For that kind of thing, basically we need again data, right? Now, again, as the same thing here, right? If you just take a microgrid, there is an investor, and then the utility is there, then the customer is there. At the same time, because if you take a utility, there are different aspects, different sections are there, like generations, transmission and distribution. Now, normally what we do in the energy sector, we take the generation cost and then we add some percentage to the transmission and percentage to the distribution, and then transfer that cost to the customer. That is normally what we do during these electricity tariff revisions. But the problem is we cannot quantify the benefit going to the community in large, because the renewable energy project, there are several other benefits. We cannot quantify them, right? For that, basically, we need data. Sometimes this data is very difficult to get it, as well as, I mean, even though the data is there, sometimes it's very difficult to quantify those data even, right? Some are sensitive data sometimes, right? Like, whether, as an example, I don't know whether in artificial intelligence, how can we do that? Like whether the people satisfactions, right? Because when the electricity is there, you satisfy, right? And whether the electricity is coming from the coal power plant or whether electricity coming from renewable. That is because you don't feel that. No, now if you just switch on a light, we don't know whether it is coming from the green energy, whether it is coming from the coal, because finally you find the electricity tariff, right? But if we can quantify it, if it is coming from the green energy, this is something like that. Then if the green electricity is coming from the coal, if it is something like, I mean, then we can quantify the benefit going to the customer. But still, I don't know. I mean, how we can do that with the data? It's still in the energy sector we cannot do that, right? We are still finding how we can do that. Now, why all these things are important? Because people are talking about, as you shown here, how equitable is this energy transition. Now, as an example, nowadays renewable, I think most of you, maybe if we count, I think most of you have your own electricity and the renewable energy on your rooftop, right? Then because if you can invest, you can get the benefit and you can satisfy that, okay, I am generating green energy. But finally what will happen is, actually it is not equitable, because the investment cost for this renewable energy, basically what we do in our electricity tariff, we are passing it to the low-end customers, right? Because if you invest for a 5 kilowatt system, assume it is 1 million, then what is happening is we calculate as per the return on investment, and we fix a charge for you, maybe 37 rupees. So nowadays it's like 27 rupees. But if you take the average cost, it's actually less. That means if you take rooftop solar, actually we are giving more than the average cost to the producer or the investor. But problem is then, in order to make it low, what we have done is, in order to make it average, we are passing that cost to the low-end customers, right? That means actually this energy transition is not equitable nowadays. right? And impacts of energy transition on energy for the poverty is always there, because that's why we are talking about this people-centric energy transition should be there. Because actually even in our country, energy access is good because it's 99%. Efficiency is also up to some level, efficiency is there, but the affordability is not there, right? It's for some people, some sector it is affordable, but for some sector it is not affordable, right? And then at the same time, promotion of clean energy. These are going in a different angle, like one is clean energy, others, because you can if you can invest more, you can get more clean energy, but then you have to, the electricity tariff will go high. That's why nowadays people are talking about it's not only clean energy, we have to promote affordable and clean energy, because it should be affordable, right? For that, actually, we need more research, more data, and see how actually what should be the best electricity tariff, or what is the best way to implement this kind of renewable energy project in Sri Lanka. Right. This energy transition, basically, there are several stakeholders. It's not, as I explained previous, it's not only the investor and the final, the person who is paying. There are so many stakeholders. Everyone should get together and do a kind of research and how to come in. Basically, I have seen this today, the Lakuna project also, they have proposed that, they have to quantify the benefit going to the customer, right? That should be done, right? We have to done that, and we have to quantify, and we have to show the community that if you do this kind of project, these are the benefits. Otherwise, if you just take the rupee value, actually people, that's why even as a secretary also, we always saying the renewable energy is not, affordable to the low-end customers. Why we are telling that? Because what we do is basically investment, 100% transferred into the customer, right? Right. What are data and artificial intelligence? If we just simply explain, AI's data is deeply interconnected, right? In our system, basically in the renewable energy sector, now actually there is one project, if I explain, there is a AI-powered microgrid is going on in one project with the Lanka Electricity Company. And there also what we are trying to do is how we can use artificial intelligence and the data and to give more benefit to the customer, because we are trying to, because there are two microgrids. One microgrids we are available at the Moratuwa University, and the other microgrids, this AI powered microgrid, we are going to develop at the Nugegoda one transformer, and we are trying to compare after the implementation. We are trying to compare whether this AI powered microgrid is giving more benefit to the customer than the normal microgrid. Right. Then if we have those data and the systems, what we can do, optimizing the renewable energy generations, forecasting, or the energy storage and distribution, because in future, only with the renewable energy we cannot go ahead. That's the issue now. We have even this government also in their policy, they are trying to increase the totally renewable energy to, I think, 2000 megawatt, something like that. But I don't think, if you add all these since 2000 megawatt and other thing, I think we will be in trouble. We cannot run the system. In order to absorb 2000 megawatt solar or wind, definitely we have to go with the battery storage, and whatever all the power plant should be connected to the control center with the data and with the real-time data. Otherwise, we cannot run this system. Right. Yeah. All these things are important, right? As I explained, I'm not going to explain all these things. Right. Finally, challenges and solutions for AI-driven energy management for this in our sector. One is data quality and availability. That's as I explained. The important is data availability whenever we require. That's the issue, right? The energy sector, we cannot do, because if we need the data in real time, otherwise we will take a wrong decision. Therefore, The data quality and availability is very important because we are doing a real-time decision making. And the other thing is cyber security. The security is very important. Otherwise, anyone can go to the system and they can do whatever changes. Then the system becomes will have blackout, because at the moment, the good thing is that because as the system is a conventional system, even if we have a blackout, at least within 2-3 hours, 4 hours, we can take the system back. But if we move into smart grid and the fully automated system, then if something happens, it's very difficult, right? And finally, regulatory and policy barriers are there, but we can change that. But other things, the important thing is cost of AI implementation, because whatever we do in the energy sector, it's huge cost. Like even if you think like from the 21st of September, there is this new government came, and now it's almost, I think, 2 months. Within 2 months, we have taken $250 million loans from the donors, right? It's huge money, right? Because 250 million for two people, I have seen that people saying like they're taking again loans and loans. Without loans, we cannot go ahead, right? Because if you want renewable energy, you have to invest, and the investment is not small, huge investments. Therefore, the investment, government does investment, then finally that investment is going to the electricity tariff, and finally all the people in this country should pay back that. Therefore, we have to keep it, remember that everything, finally everything is costly. Therefore, whatever we do, finally we have to pay back. Okay, thank you very much.
So we have a slight change in plans. I'm missing my industry partner, Dr. Narendra, for some reason is unable to be here. So what we are going to do is we are going to have the panel with 3 people, 2 people who have worked with data from electricity networks. That is Dr. Moinul Zaber, who's done most of this work in Bangladesh in very similar conditions to what we have experienced. And he's now in Cambridge and Portugal and various other places, but most of his comments will be about the situation in Bangladesh and the challenges of doing this kind of research there. So Moinul, if you come up here. And I'm also going to ask Merl, who has been with his hands deep in the data, with electricity data, to also join the panel, so that we have actually 3 researchers, but 2 will be talking directly about using distributors' data and drawing insights from that for public policy. So while we get settled, I'm going to, I think I prefer standing, so I think I'll stand here. Adolfo talked about using that most people use data to justify funding decisions. What I do is I use stories to extract data. So I'll tell you a story to begin with. That is, and it's a connection to what Professor Hemapala talked about the inequity of rich people using solar rooftop services and actually the costs being passed down to those who are poor. Now there's an additional cost that the rich people of Sri Lanka pass down to the poor. That is, they are kind and they hand over, they pass down the appliances that they no longer use. So the refrigerators, the air conditioners, various kinds of appliances that they have, they give it to people who are not as wealthy as they are. Now what happens? If you go back, the people in this room, you go back and look at your fridge or any of the electrical appliances you have, they are efficient. It says something about inverters, it says something. Those are basically efficient appliances that are now coming into the market. What they're handing down are actually inefficient appliances. So the story I tell is that somebody who's using a fridge in a rich household will be spending less money on using that refrigerator than somebody who's got a hand-me-down for free, I suppose, but their monthly bills will be higher because they're using an inefficient appliance. And I think what we can do, I said, if we can identify these people, we can tell them, we could even then, now as secretary, this is something, a proposal I brought to the ministry 5-6 years ago, which is we can have buyback programs. That is, we go to these people and you say, we have identified that you've got an inefficient refrigerator. Can we buy it back? We'll give you a coupon so that you can get a new one. Right? The government is doing that. Now, if you really think about that, now we are talking about climate change and the benefits of moving to the new technology. But here we are talking about going everywhere. It's not the people who have solar on their rooftops, the most obvious application of addressing the climate change problem. We are now addressing the climate change problem caused by inefficient appliances. So that's the story I told, and we got the data. If Narendra was here, he would have told me, well, that's not the reason we got the data. Gave you the data. But that's a story that we told. So I'm going to begin with that story, and I'm going to ask, first I'm going to ask Merl and Zaber to tell us about how you went about doing the research, finding the data and getting the research done. Maybe each take about 5 minutes. And then I'll come back to all three of you about actionable outcomes from there.
Yeah, I'll get started. So the first thing we did when we started on this particular project, we wanted to see if what Prof was telling us was actually true, whether poor people actually spend more on energy. So how we start doing this work, which eventually will end up us releasing a full and rich data set on domestic electricity consumption, we first went and spoke to people. Not a survey, but went there, spoke to people, observed them in their natural habitat, and just asked them questions around how they use energy, like what equipment do you have, how much do you spend paying your electricity bill. And some of these claims were actually corroborated, and we figured out that like for equal amount of number of people in a household, sometimes the rich ends paying less, and the poor ends paying more because they spend more, or rather they use inefficient appliances, and that costs more. So what we then did is, so what we are eventually building and releasing is a data set which has information on people's electricity consumption. You get from the distributor, in this case LECO, where you have two types of households. You have smart meter data, which has incredibly high resolution data of like daily electricity consumption. There are variations. And for households which don't have this data, we have end of month consumption unit. So we merge this data together, and we have done a survey. We are nearing the end of it, and we did 3 rounds of data collection because we wanted to see how people's behavior change over time, and at each point, like what's the setup within these households, how many people do we have. And after 2 months, if somebody has left the household, and previously it was 3 people and it is 2 people now we are able to see if there have been changes in electricity consumption, how does it map to what's actually going on in the households. Have they bought new equipment? That is captured because we collect information on people's appliances and the habits around appliances. How many times do they use a washing machine? How many hours do they have like AC switched on? So this is an incredibly rich data set that we are building. It's the real power of this data set is both the consumption data, but the incredibly rich survey data that we collect over three rounds of data collection, which has been made possible by the kind of funding setup that we have here, which I want to underscore. Because one of the things when it comes to doing machine learning, especially with like open data, is like feels good in theory, but what we find is it often lacks nuance and context, because people will just put something up there but you can't do much with it. Maybe you can explore and play around, but you can't do meaningful use cases. So we've taken data from the provider, we've understood the customers by talking to them, and then we've done a survey to systematically collect this data, and now tomorrow we are actually trying to figure out the use case that you outlined. Whether we can actually detect these inefficient appliances, if especially only from, because the real value here is, yes, we have the survey data, but if we don't have the survey data and only say smart meter data, using only smart meter data, can you actually detect the existence of these appliances? So what the survey data helps us do is to actually validate existence of a model like that. Then for households which don't have the survey data, if you have the smart meter data, if you have a well-performing model, then you can deploy that, and maybe you can do targeted outreach to see if they'll be interested.
So did you have any information about whether they are using solar on their rooftops?
Yes, we have that information.
So you can correct for that?
Yeah, we can correct for that as well. Yeah.
Thank you so much for having me here. It's a pleasure to get back to Sri Lanka after a long time. So this journey that I'm from Bangladesh, and the electricity work that I'm going to talk to you about is about what we have done in Bangladesh, and basically in Dhaka, probably one of the most populated city, definitely in South Asia, and one of the most in the world. What we did was actually the very first thing that the energy providers wanted to know was to know that, whether or not two things that they did made any difference in the behavior of the people's choice, or people's paying behavior, or people's usage behavior. The first thing was change of tariff. The second thing was to bringing in smart meter and bringing in prepaid meters. So that was the question that the energy providers actually wanted to ask, and so we got a generous amount of data, and the very first seed money actually came from LIRNEasia, from another project that we did long back, and from that what we have shown was using data, you can get three insights. The first insight that you can actually get is how people pay their bills, what time, at which part of the day, in which part of the week they pay. This was very important because the problem of delinquency in Dhaka city was high, very high. And they couldn't find out why people were delinquent, why people were not paying. And it was always saying that, okay, maybe this area people, because they have tacit knowledge about the areas of Dhaka city, maybe this area people are poor, and so they basically don't pay. Maybe that area people are not really, wanting to pay or something. But what we found is, in many cases, it was the distance from the house to the place where you go to pay is the reason why they do not go every month to pay. So the thing is, in Dhaka, if you want to pay a certain bill, energy bill, you have to go to a certain place to actually pay. The very first thing that when we showed that to the energy providers, what they did is they had a company which basically is like an online paying company, and they had a deal with them, and they started to do kiosks which are nearer to the houses. They started phone-based payment scheme, and delinquency reduced about 35%. That was number one. So when we could actually show them that there is this huge benefit of looking at data and looking at customer behavior from data, they were interested. So the second thing that actually very interesting to see is they came up with this idea that which we didn't come up actually. They said that, all right, so we know about the households. What about the the industry? is there any way you could actually say that why they are using captive power? So captive power is basically one thing that we probably all know, that the energy providers.
Let's not use technical terms. We are talking dirty diesel generators. Captive power is a technical term.
Right.
People
yes. Exactly.
running generators.
Right. It's basically generators at home or at your industry. The reason why so they wanted to know, like, why are they not taking power from the grid? Why are they actually generating their energy? Now, very simple answer to that is that they were not, they found that the grid is not reliable. Why? Because there's abrupt interruption, voltage problem, like it is always, most of the time low. Power factor is not always the one that they want. Frequency is absolutely non-coherent. Now, these are the things people, they talk about, but they use this. Well, they say that it's a way of using captive power, diesel power at home or at industry, and so what they wanted to know is, like, what is the situation. So we got data on energy quality, energy quality parameters. So it's about 600,000 hours of electricity supply. So the very first data that I talked about was in the demand side. So, how people pay bills, and from that you understand the behavior of payment, behavior of, like, reduction of delinquency. That now we actually got data on the supply side, where we actually know the parameters. We put devices in supply stations so that we could actually, get power, information about power, various power related quality factors. And then also about 400,000 hours of data in audio and on paper, which we had to digitize. Well, there are other benefits out of that, but I'll talk about that later. But the very basic benefit that we actually got from there was two. First one is we understood which transformers are the ones giving, at the supplier level, giving the worst electricity. And we found that, this very simple way of solving that is that you need to actually watch out certain transformers so that you have better power level, so that they do not reduce the amount of time they are connected with the grid. So that was one thing that they did, that we did, and they basically, rehauled the transformers with that. Number two, which actually was very beneficial, is that most of the time there were complaints. There were complaints of, power cut or not voltage coming in and everything. And there were two ways of complaining. One, in the very olden way, is that you actually put the data. Go and complain on paper, and after that, the supplier company will go and solve the problem. But actually, it's a very old way of doing that. And now with the mobile phone, the problem that the supply company had is, like, they were not, the consumers were not really happy with this paperwork thing. So they were always calling them. Now, supplier companies, they do not have many people to work for them, like 4 or 5 people to attend to the, customers. So what happened is, like, they were always, like, whenever they call, they found the phone busy. So there was no way they could actually give the customer what they needed. So you have power cut, okay, so I cannot solve it. Now, the problem, that happened from there is that very much, this is one of the other reasons why people were not using grid, but using their generators, which is the captive power. So what we did is, like, we looked at the complaints. With that complaint, we could actually geocode and find out the places where the problems were. And in sometimes, like, we could actually give them a way of, let them know, like, okay, so how long time it will take for them to actually solve the problem. So the customer knows that, okay, my information is, they're using this information and they're trying to actually solve the problem. They know where the problem is and they will gonna solve it. And number two is like, they basically had another way of solving a very important problem, which is most of the time they were running with their trucks from one place to another without planning on how to actually go from one place to another. So 25% of their movement got reduced because of using the data and planning the transformer rehauls and planning the situational problems that they had. So basically, when we had these two things, it was it was the most, significant way of solving very customer-centric problem that, these industries and the household that I'm talking about had. So I think what we naturally did is we said that, okay, maybe now we can actually use it to have an agent, which we call chatbots or conversational agent. Can we use this data to actually do that? And we found that using, as in Sinhala or in Tamil or any other South Asian languages, Bangla is also, Bangla, which is my mother tongue from Bangladesh, is a very low resource language, meaning it doesn't have that much digital presence. So giving a service through an automated system is a big problem. So what we tried to do is see if, whatever data that we have, whatever models that we actually have, can we use them to actually, give customer-centric, services. And funnily, we didn't have any data set to do that. And this data set that we actually amassed from customer information, from all sorts of energy related, like from the supply and demand side, we used that data and we found that the conversational agent that was augmented with this data was nearly perfect in a sense to give situational information to the people, which is, I think, one of the very important way of using digital technology, communication, that Professor was talking about. So, yeah.
Yeah, so thank you. I think just sort of summarize the conclusion, which is that, you see, when you're talking about climate change, we tend to think of the obvious manifestation, rooftop solar. But here are the non-obvious manifestations, which is if you have, like in Adolfo's case, less waste, less unproductive movement of containers within the yard, you are saving energy. You are emitting less greenhouse gases into the environment. Your trucks being running on more efficient paths. I was asking him whether this would be the traveling salesman problem that some of us are aware of. Making them more efficient, making that resource allocation more efficient would save resources. In Merl's case, we are talking about things that the the electricity operator, for example, LECO is all about billing for electricity. But we need to talk to the ministry, we need to talk to the government about what can we do about inefficient appliances. That is not LECO's business. So, in your capacity as secretary, as a decision maker, what do you think about this example?
Yeah, now, if you just take these inefficient equipments or appliances, my view is, now we can promote people to change their old equipment or inefficient equipment and move into the efficient systems, right? We can do that. But how to motivate that now? We can teach them, or we can do whatever the programs to them, but how to motivate them to do? Money, right? Finally, again, it's the investments, right? Now, if you just take, again, I'll take the same some previous example. Now, assume you're having solar systems, right? If you have a 5 kilowatt system, nearly you can generate around 600 or even more than 500 units per month. Now, if you have even two, 3 ACs or even inefficient fridges and all this won't come to 500 level. Then there is no motivation for him to or her to change it, because at the end of the month, if your total number of units is 400, and if you can gain 500 units from your rooftop solar, because now you have already invested this 5 kilowatt system, it's not a big investment per the person who has money, right? It's around, nowadays, it's even now less, around 750,000. In the past, it's around 1 million or 1.2. Now it is less than 750,000. You can install a 5 kilowatt system. Then once you have invested, then after that, it's nothing, right? It's zero, right? Then every month, you are earning money from this system. Then you don't worry, right? Because there is no investment. Because if you want to change your inefficient system and putting in a efficient system, you have to remove it and put another thing. You have to invest. Then it is another 200,000, 250,000, or even more, right? Why do you have to do that? Because if your cost is zero, if you don't have to pay anything, then you don't need to change it. That is the problem, right? Therefore, I don't know about if you go to some of the foreign countries, they look at in different angles, right? They look at these greenhouse gas emissions and all these things. But in Sri Lankan context, I think around more than 95% people always look at the cost. That is how much you have to pay at the end of the month, right? Therefore, my personal view is, as the ministry, we can do these things, but motivating is very important. Then in order to motivate, it should be connected to your electricity tariff. If you have done, if it is connected, if you feel at the end of the month, yes, my electricity tariff is now high, that means there is an issue, then I have to change that. Then they will look at, okay, how much is the investment? If it is 200, then if the people are like, most of the low income people, they are always look at 1 day ahead sometimes, right? They today earn, tomorrow spend. Then that kind of person, actually, is not looking at that sense. Therefore, I don't know, how to change it, how to motivate people, it's a big question.
I'll just add, because this is a proposal that I brought in 2017 to the ministry. You weren't there at that time. What I was saying was, let's just buy back their equipment. There's no cost to them, but we'll show them that their monthly bills will go down because now they have more efficient equipment. So we bought back the equipment, they can replace it with a fridge. They don't have to do without a fridge. They can have a refrigerator, which is more efficient and new, but their monthly bills will go down. And if we can provide them with the data, now I think that's a motivation. So any other actionable suggestions that you can talk about? I think you were talking to the companies. Merl?
Yeah. One of the things, we are yet to do this, but one of the things we want to test out with this data is there's research in behavioral economics that tend to suggest that if you tell people that people like you spend less on energy, of people of like the same profile, your same economic level, and same number of people in the household, that motivates people more than like many other interventions in terms of energy reductions. So like telling that your neighbor spends less than you on electricity, maybe not just the neighbor, but people like you spend more than less is one motivator. So what we can also, we are hoping to do with data set is like to group people into different categories based on various characteristics we have in the data and see if we can get not just generic energy saving strategies or recommendations based on their profile, based on their if not unique context, similar context. Can you get more targeted recommendations to these people and say like, if you do this, you might save data. And I think this is like, even for LECO, this is an interesting use case.
But I'm going to push you on that. And I think you'll have to answer to the secretary on that one. Because you see, if you don't have time-based tariffs, if you don't have low off-peak prices, I know where your examples come from. It comes from Singapore, right? Singapore has got time-based tariffs. So what you're telling the people to do is to move their use of washing machines or dryers or some heavy consumption items off the peak and use it in the middle of the night, right? But if we don't have those tariffs, we have those tariffs for some people. But for many people, particularly those in the lower income brackets, those who are using very little electricity, they don't have time-based tariffs. So that is a thing that the ministry and I know the regulator is also here, the regulator and the ministry will have to work together to create time-based tariffs. It was in 2013 that LIRNEasia proposed to the PUCSL that we move towards time-based tariffs. So think about that. Yes.
So basically, we tried that. We tested that with our data, and as because the data is like billing data of monthly payment. We could not do the time. We could not test the time-based tariff. But what we could do is we could actually see how seasonal patterns actually change the behavior. And the important thing that was that we actually designed a new bill system for the government, where we actually say that the same thing, that we just say that, okay, you are in this cluster, and similar type of person from that area is paying this amount of money, as opposed to you, just showing like 3 colors, like red, yellow, and green. Now, are you in the green zone or in the yellow zone or red zone, etc.? And so what we saw is that just showing that, and we did a survey on that, just showing that people believe that this will actually change their pattern, because they didn't know that there are other people. So first of all, like, they didn't even know how much they're paying the bill and why they're paying that much bill. That was number one that we found. Number two is like, when they're paying the bill, they didn't know that there is another same person in another area who's actually paying less than him. These two things were actually found in our work, and we actually looked at the seasonal pattern. We saw that even if you actually use electricity more in the summertime, when in Bangladesh it's very interesting that in the summertime the tariff is actually low, where in the winter time it's actually high. There is reason for that, I guess. Anyways, it is not time-based, but it actually shows that having time-based intervention really helps. There is another thing that I wanted to actually say, that the value of this data set from the energy and sustainability perspective is very high, because most of the time what happens in asserting how much money a household will be actually giving to a supply station is based not on the appliances that they use, but it's based on the connection that they actually have, number of connections that they have, at least in Bangladesh, that is. And so what happens is, because they do just simple math, multiplied by this and multiplied by that, it is always a higher tariff for those people who, the actual versus the one that is predicted is always, it has a huge gap. So what we try to see is, like, can we nudge people to understand that having a lesser amount of appliances turned on per month actually reduces your energy cost. And we tried that in 2 areas in Dhaka, in a very kind of like poor area, and the other one is like semi-poor or like middle class and poor area. We found that the poor people have better judgment of their energy consumption and usage rather than the ones in the middle class. So I think, like, there are a lot of nuances to actually get out of this type of data, for sure.
So we have a few minutes for questions from the audience, if there are any. Otherwise, I'm going to go back to the secretary and ask whether, and maybe this is an issue that was brought up, industrial uses, right? Instead of residential uses. We keep thinking about, if you recall that example, right? If we can stop the diesel generators from running, sometimes the electricity company actually encourages it because it reduces the load on their machine. But you must remember, everybody goes around talking about coal being bad for the environment, but the dirty diesel generators are worse, right? So if we can stop the diesel generators from running, we are doing good for the environment in terms of climate change. Is there a value in focusing on industry rather than on residential? If you have any questions, I can see. No, I don't see anything. Please, Mr. Secretary.
Yeah, no. Yeah, I think that's I think it's correct, because rather than going for the the domestic customers, going for industry customers, actually we can implement demand side management, demand efficiency, all these things.
They have time-based tariffs.
Yeah, they not all, because it's not, for some people it's compulsory, it's for some things it's not compulsory. Therefore, if we can make, because they are having smart meters and I think therefore easily we can implement. And even we are thinking now in future for the solar, the customers also now currently, there is no, it's not compulsory for even solar customers. We are thinking to make it compulsory for solar customers, this TOD tariff, because otherwise it's not fair. Because if you take the solar, they generate only during the daytime, and during the night they take the electricity from diesel power plants, which costly, maybe 50 rupees, 60, 70, more than that. Then a set of using the solar with the diesel cost is not correct. Therefore, at least for the solar customers, make it compulsory, as well as you explained, going for industrial customers is also, technically we can do that. We have to take a policy level decisions for that.
I don't see any hands raised. Is climate change not important to you all? But I think, just in terms of just straight economics, we use less diesel in this country. I don't know whether you know that this is the largest cost in terms of imports into this country is petroleum products, right? So we think petroleum products goes to the vehicles, but quite a lot of it goes to energy generation. And you guys saw in 2022 what happened when we didn't have money to import the petroleum. So we need to cut that down. And the only way to cut it down, people think, is more and more solar on the roof and more windmills. But we are suggesting that we can use data and we can also bring down the demand. Take this if you want. No.
Okay, it was working. Sorry, I think better use of grid is something that I would like to add in, because there is, at least, I don't know about Sri Lanka, but in Bangladesh case, there is a belief that grid will fail. Now, in that way, you will always have captive power, I'm using this word all the time, diesel power, whatever, to...
Only dirty diesel generation.
Exactly.
It has more punch.
And the problem with that this type of use is that, that you know how much diesel you actually use in the grid. We also have energy generators who are using diesel for that. But we really do not know what the industries are doing. Like how many industries are using it, when they're using it, and what is the reason for that. Now, that is a very gray area where diesel consumption is happening, and only way you can actually reduce that is to actually know the data of the quality of the energy that is given to them. When you have the data, you can make better decision. And when you make the better decision, the trust on grid will increase. And trust on grid will increase, will reduce the transaction cost. Now, I think coming to AI, as we say, I see AI as a tool that reduces transaction cost. And if you think in that way, which way you can reduce the transaction cost will help sustainability and will reduce the climate pressure. That is where we are, putting by using that dirty diesel or whatever things that we are actually using for. But the beginning of it is to actually know your grid, and to know your grid, you really need data, and open data mechanism is the best way to actually do that, because then you actually have AI-powered innovations in that as well. I'll just add one important thing. I have an experience of working in the north of the world and working in the south of the world as well. And to be honest, the energy sector in the north of the world is not also well managed. There are a lot of problems, customer-centric problems, etc. Myself, we live in Cambridge, and every month we have problem with bill, and every month we have problem with the supplier. I mean, it's not something that, something that is really something with the South Asian people. Now, so the crux of the problem is very simple, that they do not communicate with data. They do not tell us actually what's happening, so we are always in the dark. And as a user, we are always in the dark, and that's why the trust actually is low. So better data, better system actually helps us. But there is an important thing of contextualization. And if you use North data to do that in Sri Lanka, you will not be able to actually increase the trust. So the value of Sri Lanka-based data is so high, actually, in that way.
Yeah, I thought he was going to give the summary, and I could avoid doing the summary. But basically, what we are saying is, you see, when we are looking at energy regulation, we talk about demand-side management. If done properly, is the equivalent of building a power station. It's the equivalent of building a new power station. And we know that power stations of all kinds are bad. Right? Better not do that. Even if you talk about wind or solar, the damn thing has to be built, it has to be moved. All this causes greenhouse gases, right? Better try to use data to control demand, right? So that's the lesson I would take. And I said, look beyond rooftop solar, look beyond wind, look at the overall system and what kind of impacts we are having on the climate. And let's be innovative. This is not only about data, this is not only about identifying problems, this is also about innovative solutions. And we need innovation on the part of the policymakers, we need innovation on the part of the operators, we need innovation on the part of those who make comments, those who make presentations at the public hearings that the Public Utility Commission conducts at various points.